Hello, my viewers, and I welcome you all to my channel on PU Formal Academy. This is the academy that I work with my own professional experience in the industry. My name is Remain Ways Sunday. In my presentation today, we are going to answer this question. Someone sent me this in the section comments, why my phone blocks feel dead. Wow, this is a very serious question. Why my phone block feel dead? You understand? There is a block we call dead cell. So if we have live cell, that means we must also have dead cell. Now let us look at from the name flexible polyethylene foam. Flexible. Take the word flexible. Flexibility means it can stretch and return to the original size, right? That is the flexibility, just like rubber. Good. So that is how foam is supposed to behave. Foam behave like a spring. Okay? When a foam is subject to a load, it will respond. When that load is being released, it will return to the original size. And in foam property, there's what we call resiliency. Resiliency tells you how the foam bounds. We also have compression. Compression means I'm subject to load, then unload me and see what I'm going to be, whether I will return, at least recover a certain percentage of the height that I was compressed. So that is the foam. But in Nigeria, the challenges is different. The challenges is different because people feel like flexible foam is supposed to look like wood and blocks. I want hard foam, I want hard foam. And this architecture of the hard foam lead to the burning of the factory here and there. You understand? So I do not say, as a producer, you should not give your customer what they want. But at the same time, you should also play safe, okay, by not adding the foam beyond a certain mechanical property, allow the other one to suffer. You understand? So that's what we are saying. Now, looking at this, to answer this question, in the PU foam reaction, there's what we call polymerization reaction. Now, this polymerization reaction in that of PU foam is called poly addition. Okay, a step growth polymerization result to poly addition polymerization because the urethane do not form further product apart from that urethane. Then you move to the next stage of the reaction, which is the gaseous reaction. So most of the foam troubleshooting base here. Okay, why? In this case, this polymerization, it may be too soon or too late. You understand? So these are the two cases that lead to split, crack, shoulder split, cavity opening, making the reaction not unbalanced. And the attribute to this factor is temperature. Your temperature, okay? Then and one raw material known as thin catalyst. The role this catalyst will play in that reactions. You know, going back to my previous lesson, you see the role thin catalyst play at the first stage of the reaction called polymerization reaction. It acts as a cross-linker, you understand? It's the one that will activate the reaction between TDI and poly, or allow that poly addition reaction to proceed for the formation of urethane. In that case, because of variation in the temperature, if you have a high temperature, you will notice this. If you have a heightened catalyst in your reaction, you will notice it. If you also set your four-place setting of your foaming plan, you may also have this. Then if the mixing of your reaction is not synchronized mix well, you may also have this. Now the question is, how my foam feel too dead? Having known this, Let's answer this question. Why my foam reaction, my foam blocks feel dead cell? Dead cell mean my foam is being subject to load. On load, it does not return to the original size. It does not recover, or it recover late or less. That is what we call feel dead. If you press it like this, okay, it does not bounce. Are we all together? Wow, that is very interesting. I love this question so much. That is to say, the polymerization reactions of these productions occur two zone. That is why. So the polymerization reaction of these productions was occur two zone. That's why they feel there. Let me tell you, because the cell, that's what we call the polymer strength. So the polymer strength, the polymer strength developed too early. Thank you. The polymer strength developed too early. So as a result of this, making it difficult for the cell wall, okay, to burst during the gas pressure. Okay, so in that regard, it making the internal gas pressure of the foam fall below the atmospheric pressure. Let me tell you one thing. Look at this. Look at this, please. If you probe a foam under exothermic reactions, it will go here from a normal ID, but I'll start here because there's certain temperature. So the temperature of this, it go this way. This is the peak temperature. It will come down. So coming down, it will be equal to the atmospheric temperature. When this system fall below this, the foam will shrink. That's what you know. But it may not shrink completely. But by showing me this, it means that the polymerization reaction was too zone to occur during that reaction. So it now making the polymer strength develop too early. So when the polymer strength of a reaction develop too early, trying to block the cell, that is the cell wall, thereby preventing, it will not prevent the CO2 to release properly. It may release but does not release properly. So that is why that kind of a block at the curing state, it will shrink by some inches. Some will shrink completely. So some people will now experience that, because the reason that they want that foam to be harder by increasing the amount of stimulus and also increasing the temperature. So that is the reason your foam will feel dead. So to correct this, you have to cool down the temperature. You have to balance up the polymerization reaction by not allowing it occur too early. And what is that? You drop your catalyst to certain level. For batch foam, you step it down gradually. You understand? If you tend to produce 5 blocks, the first block you may not have it right. The second block you may still come down. So by third final block you should be able to balance it. But for continuous plan, you need to check at the cutoff, touch the block, press it, and see the behavior. That is, we call it unfilled behavior. How the foam be, then go back to your foaming plan and correct it. I hope this is very, very interesting. Continue to like my page, share, subscription is free. My viewers, you are going to learn a lot. You have millions of foaming technique that you need to learn, and I believe God will give me the wisdom to keep explaining this in detail for you to understand. Thank you, my viewers. God bless you. Thank you.